Hey folks, I welcome to I guess it's week 4 of game design development, and I wanted to make a video that would help to open up the possibility for making the first prototype for our game class called Apple Picker. This is out of Jeremy Gibson Bond's book, and the chapters that I assigned to you to look at before this were chapter 16, which has a game analysis of the Apple Picker game. And then reviewing some of the other chapters that we looked at earlier, I did things a little bit out of order. I wanted you to start to prototype right at the same time that you were doing this game analysis as well. Without further ado, what I'm going to do in this video is take you through the portion of chapter 16 that talks about Apple Picker, give you a couple of things to look out for with regard to Apple Picker, and then after I'm done with that, we'll go into how to set up Unity and get things started. So without further ado, as it goes, the right here I'm looking at the middle of chapter 16, and Jeremy Gibson Bond describes what the Apple Picker game has in store for you. So you can feel free to read this on your own. But what I want to be able to do is to point out a few things about the chapter that helps you to understand what you're going to be making. First is I've provided a link to a working version of the game. So if you will indulge the pleasure of playing a video game in front of you, basically this is what we're going to be making. We're going to make this game called Apple Picker. And it's so much more fun to actually just look at the game itself. So you may recognize this as Kaboom from early Atari versions, or some moment where you've seen this type of gameplay before, where the basket down here is going to be how we collect the apples that are falling from our tree. We have a tree that is spitting out some apples, and obviously we have the apples themselves. Each one of these things is called a game object, and what the game objects do is allow us to represent whatever game component that we want to have on the screen. So we really have three inner working objects here. We have the basket, we have the apples, and we have the tree. The tree is going to create or spawn the apples. The basket is going to catch the apples. And really what we're doing is we're creating an apple, we're dropping it down, and then whenever it collides with the basket, it disappears. And so I'm going to lose here intentionally, because once you lose once, it subtracts a bar, and then you lose again, it subtracts another bar, and then after you've done it, you go all the way back to the beginning. Now, this is an imperfect implementation of the Apple Picker game. It's on itch.io. It's a user contributed version of it, but you get the general gist of the gameplay. And so that's where we are. We're going to start out with that, and I'll switch over to the book, and we'll talk through it. So as I mentioned, there will be game objects that we'll be creating in the in the book. This chapter, I would say, in the exercise, the chapter takes us through the basic gameplay, describes everything, describes the different game objects, and here you see depicted here the A are the baskets, the B are the apples, and the C is the tree. And so let's look at some of the particulars there. The baskets obviously are going to be controlled by the player. The baskets move left to right following the player's mouse movements. Excuse me. When a basket collides with an apple, the apple is caught and the player gains points. The second is the apples. The apples are dropped by the apple tree, fall straight down. If an apple collides with any of the three baskets, it's caught and disappears from the screen. If it passes off to the bottom of the screen, it disappears and causes all other apples in the screen to disappear as well. This also destroys one of the baskets, starting with the top basket. When all of this is resolved, the apple tree starts dropping apples again. The third object is the apple tree itself. It moves to left and right randomly while dropping apples, and the apples are dropped at a regular interval, so the only randomness in the behavior is the left and right movement. Okay. So let's take a look at the game object action lists for this. So, basket actions. Move left and right following the player's mouse. If any basket collides with an apple, catch the apple, and that's it. Now with the apple actions, the apple will fall down. If the apple hits the bottom of the screen, the end of the round is triggered. So that's also a fairly simple response. And then the apple tree actions, move left and right randomly and drop an apple every 0.5 seconds. And so that's a variable that we can use, and we'll make use of that variable, and we can see how things go. We also have an introduction to flowcharts here, and in Figure 16.3, this is the behavior of a basket outlined in a flowchart. I'm zoomed in a little bit, but I think it's going to come up on the screen, so we should be good. So every frame, so this is on update, match left and right mouse movement. If the mouse movement is to the left, then we're going to have to adjust what's on screen so that the thing on screen can move to the left, right? If there's a collision with an apple, then if there is a collision, so if yes, then catch the apple and award points. If no, then we just update the frame, right? So we're constantly checking for collisions, and this is happening at 60 frames per second in a high-speed, wonderful environment. It might be slower than that, but that's okay. It could be 15 frames per second, and we'd still get the desired effect. All right. So as I digress about frame rates and such, you can read this sidebar about how frame rates actually work. It's a nice little brief summary of that. So the Apple flowchart has a very similar type of setup. Every frame, so on update, the object is falling. Has the object exited the bottom of the screen? No. Update the frame. Yes, end the round, right? So if the apple has fallen to the bottom of the screen, we're going to end the round. The third is the apple tree flowchart. So for the apple tree flowchart, every frame, we're going to move in the current direction, left or right, and this is not based on the mouse movement. This is based on a random movement that we're programming in. This is a tiptoe into the waters of artificial intelligence. Ooh, big scary term, but basically what this is doing is allowing the object itself to make decisions on its own. And this is a fairly simple one. It's making a random decision. Does it move left or does it move right? And we kind of flip a coin to see which way it's going to go. All right. So how we're coding this in is we're going to have a 10% chance that the tree is going to change direction at any time. Okay. And then, so let's follow the flowchart through. On update, move in the current direction that it's moving. On the 10% chance that a change direction is triggered, then we will change the direction from left to right or from right to left. Right? And then we'll continue back. Now, we also will have a check in there that says, is it time to drop an apple? Remember, we're going at 0.5 seconds, right? So 0.5 is our interval. And so we're going to be checking at that interval to see whether we should drop an apple. So this check is basically saying, is it 0.2 seconds later? Yes or no? If it's 0.2 seconds later, then that would mean that it's not time to drop an apple, and we would then update the frame. But if it is 0.5 or beyond, then it's time to drop an apple, and so we would need to drop an apple before we then update the frame. So that's really what's depicted here. And by all means, I'm super happy to answer questions about this stuff as you go. But as you program, you'll see how these decisions will be put into place. Right? So basically, when Bond is talking about how to think as a programmer in this chapter, he's really asking us to think programmatically and procedurally about how things work. So every decision, as you might have noticed in our flowchart, breaks down to a yes or no type of question. It's an if else, right? If we change direction, then if we change direction, then we depict something on screen that's going to change direction, right? Is it time to drop an apple? Yes or no, right? If it's yes, then we do something. And so that's Boolean logic, right? Boolean logic allows us to resolve things in a true or false sort of way. So when we're looking at yes, no, true, false, that's the type of logic that computers really like. So if you have a complex decision, you say, I need to go to the store to buy bread, milk, and eggs, right? A computer's going to be like, wait a second, let's break that down a little bit smaller. You need bread and milk and eggs, right? So bread and milk and eggs. You have to segment your thinking out a little bit more. So really try and boil things down into a yes, no, an and or type of logical structure as you're starting to work with programming. All right. So I'm going to take a breath here, and we'll end this chapter 16 overview as the first video on the playlist. In the second video, I'm going to take you into Unity. I'm going to skip the beginning parts, and then we'll run through the exercise as best as we can. And I'm going to key in the code, and I encourage you to do that too. But what we're going to end up doing is following through with this process from start to finish. And so intro from chapter 16 leads us to the chapter on for our very first prototype. So we're diving in. Here we go. Next video, please. Goodbye.